Lesson 23 is on the volume of a right prism. So this is going to be a little different than surface area. In surface area, we were more concerned with like wrapping paper or paint. How much do we need to cover something? Volume is how much something can hold or how much space it takes up. So it says right here, the volume of a solid is a quantity given by the number of unit cubes needed to fill the solid. Okay? Most solids, rocks, most people can't be filled with cubes or assembled from cubes because, there's kind of curvature there, but they still have volume. So what we're going to do here is we're going to kind of derive what our formula will be for volume. So let's start, though, with a two-dimensional square, okay, or rectangle, I should say. What is the area of the square? Guess it is a square. Pictured at right. Explain. Well, we could do this by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Phew! We can do that. And again, area is square units. But there's probably a little easier way to do it than to count, right? Not that I can't count to 36, but I don't know if I really want to. So we know rectangles, squares, we can do length times width. Okay? So if I look here and count how many squares, there's 6 here, and since it is a square, there's 6 here. So 6 times 6 equals 36. Okay, so you could get it that way as well. It does say to explain. So we could just say we need 36 1 by 1 unit squares to cover the figure. Cover the figure. And that's really our key word there, is we want to make sure we are covering the figure. It's not how much room it takes up, how many cubes are needed to fill it. No, these are squares. Squares cover it. So now the next part says, draw a diagonal joining the two given points, right here and right here. So let's do that. Okay, and darken the grid lines within the lower region. Okay, so really what we're worried about here is, let's just focus down here. Okay, so we're only going to be worried about the lower half of this square. We've kind of cut it into two. And hopefully what you see is a triangle. So if we wanted to find the area of a triangle, I'm going to count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 full squares, but then I got these half squares, right? So I have 1, 2, 3, 4, 5, 6 half squares. So if I add my 15 full squares to my 16 6 half squares, well, half of 6 is 3. I get 18. So to cover that, I would need 18 square units. But we've already worked on that formula, right? Where the area of a triangle is base times height divided by 2, or 1/2 the base times height. So if again, we have 6 and 6 here. So if I go 6 times 6 and divide it by 2, that's 36 divided by 2. And guess what 36 divided by 2 is? 18. Okay. So that's the stuff we've been working on. We're focused right now on areas of just prisms right now, right? Or we're moving into volumes of prisms. But this was just the two area formulas we used for surface area. But now, volume. How much room it takes up, how much space it takes up, how many cubes we need to fill it. So the next part says, what is the volume of the right prism pictured on the right? Well, volume given by the number of unit squares needed to fill the solid. So how many unit squares do I need to fill this whole thing here? Well, to kind of show you the difference. Okay, this right here would be a one by one unit square. Okay, unit square. Okay, but we also have a rough sketch here, sorry. Of a 1 by 1 by 1 unit cube. So you can see that we're adding that third dimension. So these are going to be done in cubic units because we have length, width, and height. Here we just have length and width. Here we have length, width, and height. Okay, so if I change these here, this would be length and width, and this is length and width and height. Not that you really have to change it, but we're having 3 dimensions now. So volume is going to be measured in cubic units. So notice now these aren't flat. We have these 1 by 1 by 1 cubes. But again, if we wanted to find the volume, I could just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And I know you're like, Mrs. Messing, there's going to be 36, right? We just added a dimension with height. That's not going to change the number there are. Correct. Okay. But remember, right? If you kind of notice 1, 2, 3, 4, 5, 6, our dimensions here. 1, 2, 3, 4, 5, 6. And then notice what's our height, okay? So really, we're still taking that idea of the 6 by 6. The area, this is area of the square, right? And then we're multiplying, 6 by 6 is 36, times our height, 1. That is the word height. And 6 times 6 times 1 equals 36, the same thing. So we're really going to still be using that idea of what our area formula is, then we're going to multiply it by the height. So keeping that in mind, let's look at the next figure. You're going to see it's the same type of figure, but this one says now draw that same diagonal on the square base like we did above. Okay. Okay, so again, we're only going to be talking about this one down here. I'm going to do this real quick here for us. So I'm sorry if I get a little crazy. Okay, but again, we're just talking about the bottom half here. All right. Again, sorry if it's sloppy, okay? But I wanted you to kind of get that pop of it. What is the volume of this right triangular prism? Well, notice I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 full cubes, the whole thing. And then I have 1, 2, 3, 4, 5, 6 half cubes. That should seem familiar, right? So the volume of this is 18 cubic units. Now I know that's the same thing as our area was, okay? But if we pay attention again, this size is 6 units, this side is 6 units, and then notice our height here is 1. So if I take the area of my triangle, and remember that area of a triangle is base, lower b, base times height divided by 2. I'm going to go 6 times 6 divided by 2, which is 36 divided by 2, which is 18. But then we have the height of 1. So for my volume, if I, goodness gracious, I'm sorry guys, hitting buttons here. My volume is going to be 18, the area of my triangle here, times my height. And we get a volume of 18, which we got up here. Okay, so we're like just adding levels on. So it said, how would we create a right triangle prism with 3 times the volume? Well, basically what we're going to do is we're adding different levels. Okay, so we'll squint a little bit because this might be rough. But what I want to do here is I want to add 2 more levels onto this. And some of us can really like see this easily. Some of us can't, and I'm one of the can't. It's a challenge for me to see this visually, like it's a challenge for me to draw it apparently. But notice what I did here is this looks really, really similar to this one. But this first row here, remember that had 18 cubic units? What do you think the second row is going to have for volume? 18 cubic units. And the third row, 18 cubic units. So my height here is now 3 units, but my length and my width still say 6. So 18 plus 18 is 36, plus 18 is 54. If you think back when we're thinking about volume, when we're taking the area of our base, in this case a rectangle, that's going to be length times width, which is 6 times 6, which is 36. Okay. Sorry, triangle divided by 2. Sorry. This is actually base times height, but you know what? It's not going to change anything. Length times width, base times height doesn't change, just the variables. So we get 18 here, right? So we're going to take our 18, which is our area of the base figure, the triangle, that I'm going to eventually get right here. But then we have how many of those? 3. And that is our height. So 18 times 3 works out to be 54 cubic units. So just to kind of finish up here, okay, to find the volume of any right triangle, you're going to multiply the area of the prism's base, we're going to use a capital B for that, times the height, H. Now, that height is going to be the distance between the bases. And that gives us our formula of volume equals area of the base times height. Right here, area of the base times the height, which is the distance between the bases. So we don't have to try to draw all these figures. We just need to know and use our formula.